Hey, welcome back. Today on my bench I have an NAD 3140 integrated amplifier. I purchased this one. It was part of a bundle when I bought two NAD amps. I have covered the other NAD amp in a previous video, the 2140 power amplifier, and this one's the integrated amplifier, its cousin, that has basically all the same power amplifier goodness inside, but then it also has a preamplifier, and so I expect to see a little more electronics inside. It has the same party tricks as the other one. It's got the soft clipping, the SLC, the speaker lead compensation. It also has a speaker equalization here, which is 3 positions: off, 45, and 70. Really don't know what that is all about, but it's a basic amplifier. It's got lots of nice inputs: auxiliary tuner, one phono, and two tape. It's got 2 tape loops. Let's have a look at the back. This one, the previous owner sold it to me for a good price because he said he pulled it out of storage and tried it out and it didn't work, and it's a pretty common thing. It's got all your inputs, 2 tapes, and it's got a preamp out and 2 inputs for the power amp, a normal and a lab, and that was similar to the 2140. It has a normal in and a lab in. The normal in has actually low bandpass filters on the input. It cuts out all the low frequencies, the subsonic. It has a phono input capacitance selector of 100 picofarad, 200, 320 picofarad. So you get to select your input on phono 2. It has a phono 2 here. Does it have a phono 2? Yeah, it has a phono 2 in the front. Pretty basic. It's option for bridging the amplifier, the internal amplifier. Speaker lead compensation switch and your soft slip clipping switch. 2 courtesy outlets and a fuse. Now the previous owner said it didn't work, so I have a feeling I know why, because the bridges are missing. And I happen to have a couple here, but these are 15 millimeters, and I measured the distance between these outlets and they're 18 millimeters, so it doesn't fit, obviously. But I'll have to get a patch cord to put in between here just to bridge that, and then we'll give this a test. I have a feeling it's fully functioning, but it will probably need attention like the other amplifier did. It probably had some bad caps in it, and we'll go through and we'll test it out. Alright, I was pulling out the screws for the cover, and they have a lot of wear on them, like they've been in and out of the cabinet a few times. Like really, I've seen they're almost to the point where they're cross-threaded. So somebody's been in here before digging around. I don't know what they've been looking for, but we'll have a gander at what we're seeing inside here. Looks, I got a bunch of roasted caps here in this side. Something's falling around inside, so I'll have to take the bottom off as well. But everything looks okay. Fuses are intact, all 6 of them, and I have a feeling it'll work. You just gotta plug it in and try it out. So these caps really look roasted. If you can see this here, I'll get it, zoom it in, and I'll show you. These caps here, you can see how the shrink wrap on them is shrunk. This one's actually changed color. It used to be blue, I believe. Now it's a kind of a shit brown. And these caps, same thing. They're all roasted. This thing's seen a few more hours than my other NAD amplifier. Okay, so I'll pull the bottom off, see what's rolling around inside there. So now I got the bottom cover off. I can see right away what's wrong with the amplifier. Actually, I found a couple of these. Where are they? Somebody cut a few of these zip ties and they're rattling around the bottom. So somebody's been in here before me. I just want to point out the soldering on this is a mess. I'm going to have to go through and clean up a lot of this. I think it's all factory soldered, but the flux on the board is everywhere. There's one area here where it's all roasted, and there's some resistors on the top side. I don't know what they do. I think they're part of the speaker circuit. I'm not sure because they're right next to the switches on the back panel. And it seems to be there's little 1/4 watt resistors there that are dissipating a lot of heat. There's like 3 or 4 of them here. So I'll have to look at that. And then also, let me zoom up here. There's a spot here that's all roasted. There's some large power resistors on the top here, on the top of the board, and there's a bunch of electrolytic capacitors, and they're all grouped in here. I'll have to remove this brace because it's all in the way. All these parts underneath here will need to be checked, and probably end up replacing the majority of the capacitors in this thing because they don't look. I don't know if you can see this. Zoom in a little more and get some light in there. You can see these capacitors. They used to be blue like this one. And there's all kinds of nice corrosive glue. I have to remove a lot of that. These are all roasted. There's a bunch of them all around these resistors that are just cooked. 1, 2, 3, 4, 5, 6. 6 capacitors, at least 7. That'll need to be changed out there just from what I'm seeing. And yeah, I'll have to go through and I'll check all the capacitors to be fair. I'll be doing everything. But first, let's try and connect this up to a load and see what we can get out of it, if it's working or not. Okay, so we're wired up to a pair of speakers, and I'm feeding it with a 40 hertz tone. Let's turn this on. Scratchy right channel. That doesn't sound good. When I turn it on, listen. It doesn't sound good at all. I don't like the way that makes that noise when I turn it on. I heard something marking in here. Sounds like there's something arcing in the power switch. Yeah. I don't know, I'm going to have to dig into this deeper here. Hang on. Plug this. And have a good look at this power switch. Could be a faulty switch, because I'm not seeing anything here. I can definitely hear it arcing. I don't know if you can hear it too. Try one more time. You hear that? That sounds scary. I think the first step might be taking out this power switch. Yeah, there's something wrong with that power switch. I'm going to have to pull that out. Now I'm looking at this power switch here. One screw was missing. There's two holes here, one on each side. One of the screws was missing, so I guess somebody was in here before me. Maybe taking a look at this, see what they could do. Power switch isn't going to be something that's easy to find for an amplifier of this age. And our best bet would be a substitution of some kind. Let's see what we can get here once I get this out. Somebody's been in here before because they've cut zip ties and they've left screws out. Even on the bottom panel, there was a couple of screws missing. So it's pretty clear what's going on here. Somebody was in here before me, and we'll get it. We'll get it figured out. Don't worry. It's not that hard. It's a simple power switch. How hard's a power switch? Anyways, it's pretty simple. It's on off. That's all it does. So we'll figure something out. Let's get this out for now. Okay. So you can see, I got it unplugged by the way. So these are our power connections. Some of them anyway. Why? Okay. So they're feeding power in from here. I wonder if somebody changed the wiring on this, because it looks like this has just been tacked on. Can you see that? That's just been tacked on. This one here anyway. I'm wondering there's a couple posts here that aren't being used. I think somebody took the wire wrap off these posts and attached the wires here. And does it look like, I don't know, it's hard to tell if the switch has been removed. But let's take that switch out. Let's see if you can follow along with what I'm doing here. Just going to use some solder braid on this. The thing with the solder braid is you want to use, it's instinct to want to keep your iron on there to keep it hot, but if you put too much heat on the board, you'll destroy the bond between the copper trace and the board. There's a adhesive, and it doesn't like high heat very much. So you kind of try and limit your heat on the board itself. Yes, it's going to be a little more difficult than I thought. I have to get better lighting here. All right, I think I got it desoldered enough that it should pop out. Let's give it a little pry up. It's loose. Okay. Take this pink wire off. that somebody just tacked on there. And I'll take this white wire out. And ouch, pretty sure somebody's been in here before. They looks like they've opened this switch. So I'll clean all the solder off the top here and I'll pull this cover off. You can see it here. Looks like something's been broken on the end here, and this has been taken apart. I don't know what that is. It looks like... Maybe I have another one. Let me look. Okay, I got it removed, cleaned up. Big reveal. Let's pry this cover off. I think... I just don't want springs flying everywhere. Yeah, let's see here. A big pain in the ass, this one. There we go. Little pieces want to fall out. I need a bigger screwdriver, that's what I need. Alright. They don't look bad. There is a bit of arcing going on. Couple rollers. Couple rollers, couple contacts here. I think maybe somebody tried spraying something in here. Maybe that's what's causing the arcing. As soon as you start spraying oil or something, some kind of cleaners or something, the silver contacts will... See, these are silver contacts on theirs. And they look like they've been coated with something. Interesting. What I can do is I can clean the contacts, I can reassemble. It doesn't look like anything's broken. what happens is you have this plunger here. This plunger here comes down when you turn the power on, and these two rollers push up against these leaves like this. There's one here, and then there's another one on the other side. If it'll cooperate. Oh boy. Okay, maybe I can explain here how it works. So there's a post here, this post, and the other post is didn't come out, it's stuck in the housing. But those are your connections, and what they do is they connect up with these two leaves. They rest up against there. And when you press the button, this thing comes forward. These rollers will push these leaves out, push them out. See, right now the rollers are behind the posts, so they're pushing the leaves in. But as soon as you go past that center point with these rollers, the leaves go out. And what you're doing is you're connecting from this post to one of these contacts here. And you can see those contacts in there. They're right inside there. So what I'll do is I'll clean the contacts, reassemble, and it's pretty much all you can do for something like this, other than get a new switch, which I don't think I have. I'll have to look. Alright, I think finally, after much cursing, I finally got this power switch replaced. The old one was too far gone to try and repair or do anything with, so I think it just replaced it. It works good now. And I don't have that awful scratchy noise when I turn it on now. But you can hear the protection circuit kicking in and out. I have a feeling there might be DC on the line. If I switch the speakers in and out, you hear that DC. So let's measure that right now, because that's something that we have to deal with. Let me get my multimeter set up. Alright, got my multimeter set up. My speakers are on channel B, so when I switch B on, you can hear that. Switch is a bit dirty too. So I'll leave it on A, and let's check the left channel. Okay, here's left channel. We got 137 millivolts there. Take the other channel, and we got 330 millivolts. And I remember from the other amplifier that had to be set up because it was out quite a bit. Let's do that right now while we're here. Let's set up the amplifier DC offset. So let's get the probe set up. Do the left channel. We got a reading of about 120 millivolts. Get the screwdriver here. If I can remember which one it is. all over the place with this measurement. Turn it down to right about there. 5 or 6 millivolts. Okay, let's do the other channel. And this one was at, oh, it's at 240. There we go. Starting to go down. Six or 10 millivolts. It's better than what it was. So let's disconnect that. Let's turn the speakers back on. And you hear nothing. It's silent. So that's what it should be. Okay, we're on. And we have the tone. Scratchy pots. Let's get a decent tone here. You can see. Sure is scratchy. I'll have to do some cleaning on the pots. Both channels are working, that's a good sign. We've got some caps to replace, pots to clean, switches to clean. So I'm going to get busy on that. I have this display board, and I got some conductive glue on here. I want to show you the damage it does, because I found conductive glue all over some of the spots on the board on the amplifier itself, and I've been cleaning it up. Thankfully there's no serious damage, but I just want to show you what it does. Now this is the meter board. It's got a couple of LEDs here to show what mode it's in, and that's got a power meter, and it's on this end there's obviously a higher voltage input, so what they're doing is they're knocking it down with this resistor, and I think there's a Zener diode in there too. But there's a fair bit of heat dissipated here on the end of the board, which is okay. These two capacitors tested out fine. They're far enough away. This ceramic capacitor looks pretty cooked. It's all black. I might change it, but it probably tests out fine, but it's just, you know, it doesn't look good, and it's getting cooked. This is a 470 ohm resistor, and that's one pumping out all the heat. So I'll deal with that in a bit. But I just want to show you this conductive glue, and I'll zoom in and show you. My wires are too short here. Let me move this around so you get a better view, center and infield. So, and you can see it here. This is the stuff, and once it ages, it turns black. Usually with heat, it ages. The stuff that's not turned black, it's kind of a tan color, brown, and it doesn't seem to affect. But once it gets to this black stage, all hell breaks loose. Now they souped it up onto this, on these two driver chips here. I don't know why. But you can see the corrosion was already starting to set in on this pin. So what we have to do is remove all of this conductive glue and stop that current leakage, because that's what causes the corrosion, is current leakage. So clean all this up. Gotta get some between these diode legs here. Okay, I got that one cleaned up pretty good, and you can see it. But it left the board all black. It stained the board, which is no big deal. It's not anything there. I have a feeling, I'll have to look at this, but I think it might have gone under the chip. So I might have to pull this chip out and get that glue out from underneath it. I think there is glue under there. Let's have a look at this side. You can't see it. The glue is even up on the end of the chip here. You see it? And that little spot of green fuzz there, that's corrosion, and that's coming from the lead frame of the chip itself. Because if you look at the end of the chip, sometimes the lead frame that the die is mounted on, it protrudes out the back or the sides, and that's what's getting corroded there. There's a little dot there, you see it. But here, it's not a big deal, other than it's current leakage for one thing, which can upset the circuit, and then eventually over time it's going to eat through the conductor or whatever when it's corroding. So I'll clean this off. There, I think I got it. Come on, stubborn. There. So that's what you got to do. You got to clean that stuff off. Hopefully I got it all. What I might do is just pull this chip just to check underneath. And if I find anything underneath this chip, I might pull this chip too, just to make sure that we're safe. It's a display. It's not a big deal. It has nothing to do with the sound quality or its performance, but still, it's something we want to get cleaned up. We don't want to let this continue. So for the power switch, I completely removed it from this board. It was sharing a board with the speaker selector switch, and the switch that was on there had been removed before by someone and taken apart. I could tell it was taken apart because there was pieces broken, and pieces of plastic were broken. So somebody was in here before, took the switch apart, couldn't do anything with it, so they put it back together and then reassembled it. But the power switch was arcing. I heard it, definitely heard it when I first powered it up. The switch was arcing inside, even though there's two sets of contacts wired in parallel. So I decided just to dump that switch, remove it from this board, and I mounted a separate switch, power switch, completely independent of that board, and it's going to still mount in the same location. It's just that there'll be no electrical contact with this board anymore, and this will do the business. I'll turn it on and off. So the more I look at this this amplifier, while I do like the amplifier, I don't like its build quality. Some of the stuff I'm finding here, like look at this heatsink. It's all razor sharp here. You slice your hand open on it. But look what it's going to do to this cable wiring loom. It's just, so I'm going to bust this piece off here, just because it's totally not what we want near our wires. I think that's a little better now. But there's so many things that I'm finding that are just, the build fell flat in its face as soon as it hit the factory. So I'm just going over the board here and resoldering a lot of these switches, right in this heat zone here, this is the power supply area of the board, and there's a lot of power resistors. This is where I've placed the majority of the caps. There's power transistors here, and they're all susceptible to cracked solder joints. But I'm having a hard time seeing this board because it's so caked up with rosin flux from the factory. So what I'm doing is I'm just cleaning it. Just pour a little alcohol on, and just take a toothbrush and just scrub the crap out of it. You gotta be careful because alcohol is flammable. You don't want to blow yourself up or start a fire, but you gotta be aware of that. But you just gotta knock off all this rosin flux, because you can't really see the connections if they're all caked up with that crud. And do this a few times and you'll get it all up. Look at how my rag is just saturated with flux now. So I'll keep working on this, and then I'll go through and I'll visually check all these connections on both these boards, just to make sure we don't have any cracked solder joints and any sneaky gremlins that will appear in the future. Alright, I've gone through and I replaced probably 35 caps or so in the power supply. Mainly in the power supply they were bad, and you know, all over the ones in some of these in the power supply were just destroyed by heat. But I replaced you know, others just because they had high ESR, so they're gone. Put those aside. I'm not going to test them. Here's a ceramic cap that was on the display board, and just so you can see, it's probably still good even though it's cooked. It's a 100 nanofarad cap, and it comes out at 74, 75, which is, I don't know, it's okay, I guess. It probably would have lasted, but I replaced it anyway. Now I want to look at some of these caps. These are some of the worst ones. Here's 1000 microfarad at 6.5 volts. This one comes back at 900 microfarads, but it's got an ESR of 1/4 of an ohm, which is way too high for a 1000 microfarad cap. This one here, and you can see this cap, it got roasted, and the heat shrunk even more. Let's test this one. Even though they look terrible, this is a 10 microfarad 100 volt cap. Even though it looks terrible, it still comes up at 10 microfarad. But it has an ESR, you know, 14 ohms, which is unacceptable. Here's another one, the same thing. It's pretty much baked, and let me get some better lighting here. You can see it's baked, and it's not blue anymore, it's brown. So let's try this one out. And you'd think it would be terrible, but it's actually 11.6 microfarads, and the ESR is down around 5, which is, let's see, probably double what it should be. It should be about a 2 ohm ESR. This one's another 1000 microfarad, 6.3 volts. I find that low voltage capacitors like these, they usually burn out fast. The very low voltage ones, the 6.3 volts, and the 10 volt caps. So again, here we got the microfarads are good, but the ESR is terrible. Let's go through some of these. I replaced a whole bunch of these 47 microfarad 25 volt caps. They all seem to fail in unison. So here, I'll take a couple here and show you what I got. So this is a 47 mic at 25 volts, and I got 24 microfarads at 12.5 ESR. That's no good. Here's another one. Another 24 microfarad at 14 ESR, that's no good. Another one. 23 microfarads at 13. So they have like a, it's almost like they were designed to fail, maybe. I don't know. Alright, here's a 10 volt 47 microfarad. I've replaced a number of these too. Not because the microfarads are down, but because they were borderline ESR. And I replaced a pile of those ones. I'd rather just go in and shotgun the capacitors and replace all of them. This one's 10 microfarad at 35 volts. It's down to 8.5 and 46 ohm ESR, which is garbage. And these are the worst ones of the bunch. These were in the power supply around. These were nestled in around these power resistors. Those awful power dumping resistors. And you can see, I'll show you the heat shrink on these. They all turn brown, and the heat shrink just gives up. It's almost like the heat shrink slides down to the bottom. You can see it's all folded up in the bottom. But anyways. So, this one here is, I don't even know what they are. I think they're, I can't even read them anymore. This one's a 10 microfarad, 35 volts. This one here is, I can't even read this. Where's my eyepiece? What is this cap? This is a 10 microfarad, 35 volts. Okay. And it's reading 222 picofarads and 1.8 megohm ESR. That one's definitely gone. That one might be for the Hall of Fame. Here's another one. Oh, this one's down to 194 picofarads, 2.2 megohms ESR. That one's even worse. This one here, $228 picofarads, 1.8 megohms. So we're all starting to see a pattern here. Now this one looks a lot better. Here, let's try this one. It's not as cooked as the other ones. Oh, 236 picofarads, 1.4 megohms. So, you know, there's your problem right there. These were picked out of the power supply. And, you know, right there. I didn't examine the circuit to see what they do, but it doesn't matter anyways, they're gone. Now I usually pull out these the power filter caps, the main filter caps I should say, to check them, because it's pretty impossible to check ESR and microfarads in circuit. Plus I had a lot of that conductive glue around the bottom, so I pulled the caps out and cleaned the glue off the boards, and these feel hollow, like they're, I don't know, they feel funny, like they have no substance to them. So let's check a few of these. And these are 4700 microfarad at 50 volt. All four of these. They're all 50 volt, 50 volt, 50 volt. Even though on the schematic, two of these are supposed to be 63 volts and two of these are supposed to be 50. But however, whatever reason, they all ended up to be 50 volts. But here's the first one. And it comes up at 1800 microfarads and down from 4700. So that's kind of a fail. Here's another one. This one comes up at 1700 microfarads down from 4700. That's another fail. 1600 microfarads. The ESR isn't bad on these, but it's just that they have no capacity left. From 4700 down to 1600, that's quite a fail. And last one, you got 1700 microfarads, same thing, same story. So what I'm going to do is I'm replacing all 4 of these because I obviously can't leave these in circuit. They're just not performing. And the amplifier will fall flat in its face, I'm assuming. What I want to do is I want to put these caps back in the amp, and then let's do some power testing. I got new caps on order. They'll be here this afternoon. And then after that, I'll replace them with the new caps, and we'll do the same power test. And we'll do an A/B comparison just to see how these old dried up caps affect your performance. Alright, well, you won't believe this. I was going through the alignment of the amplifier, and I couldn't get the bias trim on either channel to work. And I scratching my head, and I just pulled out my ohm meter and checked the pots, the 2 trim pots, and they're both open. Now, test them here again. See, I got no ohms whatsoever. It's open circuit. On this one, well, that's already, let's see here. I'll set that to center, and then I'll check it along the both bottom legs. I got nothing. Here I got a short. What's going on with this thing? It's like it's busted or something. It's falling apart. Still got nothing. On this one, let's check this one. These are supposed to be 500 ohm pots, trim pots. And this one measures nothing. Open circuit. So what I'm going to do is I got a couple of 10 turns here, and I'll put these in. These ones I should check them before I use them. It's 500 ohms, 497. And this one, this one's 535. Both pretty good. I'll install these 2 10 turns, and then we'll get back to work on aligning this amplifier. Okay, after much to do, I finally got this amp running again after replacing the bias trim pots. They caused me a lot of havoc. So we're going to do a power test, full power test, with the old main filter capacitors, the ones that measured 1700 microfarads when they're supposed to be 1400. Ignore the LEDs, it's just bleed through from my light, you can see. Okay, so we got 1000 hertz tone hooked up, and the dummy load, and 8 ohm dummy load, and we're going to start turning it up here till we get clipping. When do we get clipping? Right about here somewhere. So I'm measuring 24.75 volts RMS. Now if you notice, if I go higher, you see that fluttering? That fluttering on the top of the waveforms? That's the 60 hertz ripple coming through from the power supply. So let's pop those new capacitors in, and then we'll try another power test. So what I decided to go with for this amplifier for main filter caps is I'm replacing the 4700 with a 6800. Same voltage, same physical height, smaller physical diameter, and these will work perfect. Okay, I got the new filter caps in. Let's turn this on and do a power test. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Same 1 kilohertz tone. Everything's the same load. So you notice there's, on the clipping, there's a lot less flutter on the tops and bottoms. And right about there is my clipping max. Right there. I'm at 25 volts even RMS on the output. So I think it's a bit of an improvement. Let me see if I can get this a little better. Yeah, 25 volts is pretty much it. So it's a little A/B comparison for you. Okay, well I think that wraps up this one for now. I think I got through all the bugs. I got a transformer. I can feel a hum here. Wonder why that is. Anyways, I think that covers all the bugs that I got out of it. Quite a few actually. The parts list for this one was long, and as you can see, I got a big bag of parts here that I changed out. Power switch, replaced power switch that was faulty. I can't remember now. 30 some caps. I got 2 trim pots for the bias adjustment. 4 main filter caps. Something else too. Oh yeah, there's a few resistors in here too that I found that were burned out. But she's good now, and I think this will make somebody happy. I think this is a good. It's a good amplifier, and I think I'm going to sell this one on. I'm not going to keep it, but yeah, it should work for somebody. All right, thanks for watching.